Suppose you are considering an investment which requires a huge initial investment at the beginning and it will generate return or the cash flows in the future. How do you make whether to invest or not to invest decision? And there are different tools that help us to make those kind of decisions. I have listed here from net present value, internal rate of return to the profitability index. In this video, I'm going to explain how can we use modified internal rate of return to make whether to invest or not to invest decision. So let's start with a simple definition. What is modified internal rate of return, or MIRR? So MIRR is the discount rate that makes the initial investment equal to the terminal value of that project. And now the terminal value of the project is a little technical. It seems technical at the beginning, but I hope by the end of this very video you will be able to understand what that terminal value is and in fact what MIRR is. But before I move forward, I just want to explain to you how do you make whether to invest or not to invest decision based on MIRR. So the simple rule is, if the project MIRR is greater than or equal to the project required cost of capital or the cost of capital, it should be accepted. Meaning, if the MIRR is greater than the cost of capital, then you should accept the project. Inversely, if the project MIRR is less than cost of capital, then you don't take that kind of investment because the return on your investment is less than what you have to pay for the fund you borrowed to finance the project. Let's move on with an example, and I hope this example makes sense to you. And I have designed a very simple example in which the cost of capital is 10% and you need 45,000 initial investment. If you invest 45,000 at the beginning of the period, then the investment will generate 28,000 after a year, 12,000 after 2 years, 10,000 after 3 years, 10,000 after 4 years, and 10,000 after 5 years. And what is MIRR for this project? So remember, MIRR is the rate that makes the initial investment equal to the terminal value. So for us to understand that, we need to understand here what that terminal value is. So here I have calculated what the terminal value of this project is. And one of the fundamental assumptions of this MIRR is that once you make an investment and after some time the project will be able to generate cash, and when you are able to generate cash, you can reinvest that cash. That's the fundamental difference, and that's how this MIRR makes it different from IRR, which is internal rate of return, and MIRR is modified internal rate of return. So for this example, you invest 45,000, and after you invest 45,000, first year's cash flow is 28,000, second year cash flow is 12,000, third year cash flow is 10,000, fourth year cash flow 10,000, and fifth year cash flow 10,000. So after you get first year cash flow, you should be able to invest that. And now we have to make some assumption. So you borrowed the capital at 10% to finance the project, and after a year you were able to get 28,000, and you should be able to invest that. And what should be the reinvestment rate? It could be different from the initial cost of capital, or it could be the same, but for this example I have assumed that, let's assume that reinvestment rate is 8%. If you can reinvest your future cash flows at 8%, what will be the value of each cash flow at the end of that project? So first year you get 28,000, and the project life is 5 years. So after first year, how many period is left? 4, right? 1, 2, 3, 4. So how much will that be after 4 years then? That's what I have calculated. How do you do this? 28,000 times 1 plus 8% to the power 4. And that gives us what is the terminal value of this 28,000 after 4 years. Similarly, you get 12,000 after 2 years, and you can reinvest that at 8%. If you reinvest that 8%, how much will that be at the end of the project life? So after 2 years, there are 3 years left, so you have to calculate how much will that be after 3 years. That's why you multiply this 12,000 by 1 plus 8% to the power 3, and that is going to be 15,116.5. Similarly, after 3 years you get 10,000. How much will that be at the end of the project, right? So after 3 years you have 2 periods forward, so you have to find the terminal value of this 10,000 after 2 periods. That's why you multiply 10,000 times 1 plus 8% to the power 2, and that is going to be 11,664.00. And similarly you get 10,000 at the end of fourth period, and you will still have one more period or one more year. And to find that the terminal value of 10,000 after a year, you just multiply 10,000 by 1 plus 8%, and that's going to be 10,800. As far as the last cash flow, 10,000, that comes at the end of year 5 is concerned, that's already is at the end of the 5th year, so its terminal value is the same. So now you calculated the terminal value of each future cash flow, right? So if you add all of these future value of your future cash flows, then the total is going to be 85,674.2. So this is called the terminal value. Makes sense, right? So what is terminal value? So the terminal value is for each of the cash flow, right? For each of the cash flow, you find the future value, and as soon as you find the future value of each cash flow, you add them all. If you add this future value of all cash flow, and this total sum is called that is the future value of all cash flows, future cash flows at the end of year 5, and that's called the terminal value. So now for this case we have a terminal value equals to 85,674.2, and now the initial investment is 45,000. Now the question comes, what rate of return makes, or but let me put it the other way, what rate of discount makes that terminal value equal to the initial investment? That rate of discount is called the modified internal rate of return. So if you look at this right here, I started from the equation from the last slide. So initial investment is 45,000 and terminal value is this guy right here, 85,674.2, and 1 plus MIRR to the power 4. And now you can rewrite that equation. So 1 plus MIRR to the power 4 is going to be 85,674.2 over 45, and if you simplify that equation, then your MIRR is going to be 13.74%. So what is this then? That means, as I explained at the beginning, 13.74% is the rate of return that makes the initial outflow equal to the terminal value of the project. And whether to undertake this project or not depends on the cost of capital. So we compare MIRR with the cost of capital, right? And if the MIRR is greater or equal to the cost of capital, then we undertake this project. If MIRR is less than the cost of capital, we do not take this project, because in that case the return on that investment is less than the cost that you have to pay for the borrowed money. So let's do this. Let's see this, how do this in Excel. And I have given a very short explanation how you can do this in Excel. Excel has a MIRR function, and this has an argument values, finance rate and reinvestment rate. Value refers to all the cash flows starting from current period. Finance rate, that's the interest rate that you have to pay for your borrowed money. And reinvestment rate, that is the rate you can get if you reinvest your future cash flow. And keep in mind again, when you use MIRR, at least one, and mostly the cash flow in year 0 should always be negative. Keep this in mind. So let's see how we do this in Excel. So same example here. I have 45,000 of investment at the beginning and future cash flows, as we explained earlier. And in Excel, how you can do, remember in Excel, MIRR, values basically means all of these values, and finance rate, this is our cost of capital, and refinance rate or the reinvestment rate, which is this guy, which we have assumed 8%. So if you know all of these values, how can you do this in Excel? So in Excel, as usual, I put the cost of capital on the top, 10%, reinvestment rate 8%, and we are supposed to find MIRR and period in column A and all cash flows in column B. So how do you find MIRR then? So MIRR and B5 to B10, it means it's all your cash flows. B1 is the cost of capital and B2 is the reinvestment rate. So if you do that, so you are gonna get 13.74%, which means the modified internal rate of return for this project is 13.74%. And whether this is profitable or not, how do you know this? You have to compare this with the cost of capital. So for this example, the cost of capital is 10%, and the MIRR is 13.74%, which means MIRR is more than the cost of capital. That is why this project is beneficial, or if you undertake this project, it is going to create value. I hope this makes sense. Thank you.